All right. So here's our objectives for today. Simplifying radical expressions. That's our target. Okay. So you should be able to say, I can simplify radical expressions with rational exponents. You can explain and know when it's in simplest form. And then we can simplify variable expressions containing rational exponents and radicals. Okay? So that's what we're doing today. So we already went over the homework yesterday, right? Yeah. All right, so here we go. Properties of rational exponents, all right? So let's move this down. Okay? A to the mth power times a to the nth power. What do you do with the exponents? Just add them, right? The base is the same. When the bases are the same, you just add the exponents. All right? So there's an example. 5 to the 1/2 power times 5 to the 3/2 power. 1/2 plus 3/2 is 4/2, which is 2. So that's 25. Okay? Power of a product. You got a power inside and a power outside, right? Product means to do what? Multiply. So we're going to multiply the two exponents when it looks like this. Okay, so 5/2 times 2 is 10/2, which is 5. So then it's 3 to the 243. Again, you could put these in your calculator. It does it, right? If you've got a product inside the parentheses, okay, that means to raise everything inside to that power. All right, so let's go up here so I can get them out of it. So this is the same as 16 to the 1/2 and 9 to the 1/2. Remember, the 1/2 power is like the square root, right? So that's the square root of 16, 4. That's the square root of 9, 3. 4 times 3 is 12. Okay? Negative exponents. Okay? Move it to the denominator, right? Well, that makes sure your base is not 0. So 36 to the negative 1/2 power is like 1 over 36 to the 1/2. Remember, the 1/2 power is the square root, so the square root of 36 is 6. So it becomes 1/6. Zero exponent. Whenever the exponent is 0, what's the answer? Not 0, 1, right? All right, quotient, what's that mean to do? Divide. So if you got the same base, what do you do with the exponents? You subtract them, yeah. Right. So the example 4 to the 5/2 over 4 to the 1/2, you do 5/2 minus 1/2, which is 4/2, which is 2 again. So that comes out to be 16. And this last one, if you have a fraction inside the parentheses, that means the numerator and the denominator both get raised to that power. And 1/3 is the cube root. Cube root of 27 is 3. The cube root of 64 was 4. Okay? Again, you should be able to do those in your calculator as well. All right? We're going to simplify them with radicals, though. Okay? So instead of putting it in your calculator, we just do 1/4 plus 1/2. Well, what is 1/2 in fourths? 2/4. So what's 1/4 plus 2/4? 3/4. So that's simplified. Okay? When they say simplified, they don't really want, unless they say write your answer with hundreds place or something. You don't have to put it in your calculator. They just want it in simplified form. So we want always this exponent to be simplified. So you don't want 6/8. You would want to change it to 3/4, right? Yeah. But we're just adding the exponents when the bases are the same. Okay? Here the bases aren't the same. So what we're going to do is we're going to take this 1/2 times 2. So what's 1/2 times 2? 1. Okay. What's 1/3 times 2? 2/3. Yeah. You just multiply by the numerator, right? You don't multiply them both. You know, the way you can think about it is 1/3 times 2 is 2 over 1, right? 1 times 2 and 3 times 1. Right? So some kids want to do both when you do that. Okay? So that's our problem. Answer in simplified form. Okay? Questions so far? Again, you don't have to put the 1 for 6 to the first. You could just write 6, right? Same idea here. What's 5 times negative 1/5? Negative 1. What's 5 times negative 1/5? Negative 1. Now, are we allowed to leave negative 1 there? No. We want our answers, when we're simplifying, our exponents to be positive. So how do I make negative 1 into a positive? Good. 1 over. Sorry about that. So this would be 1 over 4 times 1 over 3. Could we simplify that? Yeah, what's 1 times 1? What's 4 times 3? 12. Okay. We good so far? Yeah. All right. I don't think there's a D. Yeah. All right, there's D. What's the exponent for the top 5? We just didn't write it. 1. How many thirds is that? 3/3, right? So, what's the rule when you have the same base and you're dividing? What do you do with the exponent? You subtract them. So what's 3/3 minus 1/3? 2/3. 2/3.
Oh, it's only 2/3.
Yeah, 2/3. So there, we're going there, right? Okay. Since these have the same exponent, I can simplify 42 over 6 and make it what? 7. So this is the same as 7 to the 1/3 times 2. You guys see how I got the 7?
No.
It's just 42 divided by 6, since 6 goes into both, right? 7 over 1, which is 7. And they're both a third, right? So if you want, you could think about it like this, if this helps you. If that helps you. Now, what's the rule with the 1/3 and the 2? Do I add them, multiply them, subtract them, divide them? What do I do? Multiply them, right? That's what we've been doing, right? Making sense?
Yeah.
Not so bad, right?
So far.
So far, so good. I think that's it. Yep. All right. Some more radical properties. Okay. So, product property. If you can split it up, it's like doing our factor trees, right? We have a number underneath, but we do a factor tree. Basically, that's what we're doing. Okay. So we split. You know, if we have these two and it's the same root, they're both cube roots, I can multiply those together. And if I do the cube root of 8, we should, know by now it's 2, but you could do a factor tree for that and get 3 2s, right? If you have the same root, okay, you can change it to a single root, or if it's a single root, you can change it to separate roots with the same one. This is 4th root. But can you divide 2 into 162? Yeah. So they simplified it to 81. And then if you did the factor tree for 81, you'll see that there's 4 3s. That's why the answer is 3, right? When it's the fourth root, you're looking for a group of 4, right? So there's a group of 4 3. So that's why the answer is 3. Okay? So simplifying. Here's what I like to do. You can multiply those if you want. Okay? But I like to do the factor tree. All right? So I got a 4 times 3 and a 2 times 2. I got a 6 times 3 and a 2 times 3. What? I'm looking for a group of how many? Why 3? Because that's our index, right? It's a cube root, right? So, if you look here, 2 comes out, right? And if you look here, what else comes out? 3. And when you pull them out, you add, subtract, multiply, divide. Multiply. So what's our answer? 6. Okay? Questions?
Do we have to factor tree?
Or do what?
Calculate?
You can do calculate. Since these are both the same root, does 5 go into 80?
Does.
Yeah.
Yeah, how many times?
16.
16. And then that's 4 times 4, 2 times 2. I'm looking for a group of 4, so what's my answer? 2, right? So if you're using your calculator, that's fine with me. How do I get 4th root again? 4, math, 5, 80, divided by 4, math, 5, what was it, 5? Okay, here, this is important. Okay, all eyes up here, listen. If you get a whole number, like we did, it's good. If you get a decimal, like a 2 point whatever, then you got to go back and do the factor tree and put it in simplest radical form. Okay? Make sense what I'm saying? All right, unless your directions say round your answers to nearest tenth or hundredth, then you can leave it as a decimal. But most of the time when we say simplify, we want it in simplest radical form, and sometimes it comes out to a whole number. And if it does, that's fine, using the calculator. Like those two came out to whole numbers. All right, so the expression involving a radical with index n is in simplest form when these 3 conditions are met. No radicands, that means the number under the radical sign, have perfect nth powers as factors, like perfect squares or perfect cubes or perfect fours, right? No radicands contain fractions. You can't have a fraction under there. It's got to be a whole number. No radicals appear in the denominator, right? Not allowed to have radicals in the denominator. We talked about that earlier with square roots, right? All right, so if you wanted to do this, cube root, there's a cube root in math, it's number 4. I get a decimal, so am I allowed to use that answer? No. Okay, I have to do my factor tree now. All right, so 1 plus 3 is 4 plus 5 is 9. So what do I know about that number? 9 goes into it, right? So I'm going to start with 9. And what is it? 9 times 15? Is that right? I think it is. And I got 3 times 3 and 3 times 5. I'm looking for a group of how many? 3 because it's cube root, right? So what can I pull out front? What's left? 5. Now it's not square root of 5, it's what? Cube root. So don't forget to write the index. You're used to just doing square root, right? We've done that before with square roots and simplifying. But remember, you gotta use the same index. All right, the first thing I would try to do,
So was that the answer to that?
yeah, that was the answer. 3 cube root of 5. Okay, if I can divide 8 into 7 and simplify that, I would. Is there a number that goes into both 8 and 7? No. Okay. Are we allowed to have radicals in denominators? No. Okay. Now here's what I do. I do a factor tree for this, so I don't have to write really big numbers under here. So I see how many 2's? 3. How many do I want? 5. So how many more do I need? 2. You with me on that? Okay. So I did a factor tree to see how many of a certain number's in here. We see there's 3 2's. Since it's the 5th root, I need a total of 5 for that radical to go away. So I got to multiply the top and the bottom by 2 more, which is, if you want to write 4, you can. Okay.
Couldn't you just continue the factor tree with like the either 2 times 1 for the 2 that's underneath the 4, then the 2 has 5 2s?
No, because you get it down to, when you just have 1 as a factor, you have to stop. Okay, because it's prime. All right. So if we look at the bottom now, we have 5 2's, right? That's what I want. If it was 4th root, I'd only need 4. If it was cube root, I'd only need 3. Okay? So you need that number of the same, you need 5 of the same thing. Okay? Now, that's a 4. So what's 7 times 4? 28. So I'm just going to make that a 28. But what's the bottom now? Since there's 5 2's and it's the 5th root. Somebody said it. Nolan, did you say it? Somebody said it. Was that you, Vince? What's its answer to the bottom? Since there's 5 2's, what can I pull out?
32.
No, not 32.
Sorry.
Look at this one. Since there were 3 3's under this, what do we do with the 3? We pulled it out
3 times.
front. So we pulled a 3 out, right? And we wrote one of them, right?
Yeah.
Okay.
Yeah. It's a good
So-
yeah. 2.
So a 2 comes out, right?
Oh yeah.
So this is a 2 now.
Yeah.
Okay. Now I understand what you're saying, Caleb. If you wanted to write it like this, and then know that the answer is 2, that's fine.
Yeah.
Because you multiplied all the 2 together, right? Yeah. Is that making sense? Okay.
Wait, so which one's right? 32 or 2?
Well, the 5th root, this is the 5th root of 32, which is, the answer is 2, which goes there. You want a whole number there. Okay? You don't want any radical. That's why we did that. Okay? All right. How are we doing on time? We're doing all right. Okay. So, I would do 5 times 100, 10 times 10, 5 times 2, 5 times 2. What am I looking for? I see 3 5s. So what number can I pull out front? 5. Cube root. What's left? 2 and a 2. 4. Okay. With me on that one? Okay. So, what do I have to do on the D one? I heard AJ, what'd you say? 2 and 2. So what do I need to multiply by? Everybody understand why? Any questions? Emma, you understand why? There's, how many 2's do I need? Well, I mean total though. 4. So I had 2, but to get 4, I need 2 more. And whatever I do to the bottom, I also have to do to the top. And what, again, you guys know 2 times 2 is what? 4. So what's 4 times 19?
36.
What? 76. Thank you. What's the bottom going to be? Well, it's the 4 through to 16, right? But there's 4 2's under there, so what's the answer? 2. Okay?
You pull the thing under the radical sign, the radical sign goes away.
Correct. When you have that, when you have the number of 2's or 3's or 5's, whatever it is, that matches the index, right? I needed 4 2's, then that radical goes away.
Where is this?
2 times 2 is 4 times 2 is 8 times 2 is 16. But you don't have to do that part. You see that there's 4 2's, right? So you know the answer is 2. Good questions. We following?
Yeah.
Okay. When a denominator is a sum or difference involving square roots, multiply both the numerator and denominator by the conjugate of the denominator. Okay? So expressions like a radical b plus c radical d and a radical b minus c radical d, they are conjugates of each other. Okay? So, I have to multiply, since there's a radical here in the bottom, the conjugate of 5 plus radical 3. What is it? Say it louder, Brock. Right. 5 minus radical 3. To both top and bottom. Okay? Now, what's 1 in the top times 5 minus radical 3? Yeah, 1 times anything is itself, right? Now, how do I multiply these? FOIL. Very good. So, what's 5 times 5?
25.
What's 5 times negative radical 3? What's radical 3 times positive 5? What's going to happen to those? They're going to cancel.
Oh, yeah.
What's radical 3 times a negative radical 3? What is the square root of 9 now?
3.
So what's, no negative, it's no I.
Oh, negative 3.
This negative 3. So what's 25 minus 3? 22. That's our answer. Okay? The shortcut is just going to be square the 5, all right, minus square the radical. Well, when you square the radical, it's whatever's underneath there, right? So basically, square that number minus and that number. So 25 minus 3. That's what's always going to work with the conjugates when they're radicals. Okay? Make sure you have it in the right order. Is this in the right order? No. What? So the radical should be in the back. So what? Rewrite this in the right order. Negative 2 plus radical 7, right? You with me?
Yeah.
So what's the conjugate of this? What's the conjugate of negative 2 plus radical 7? Negative 2 minus radical 7, yes. So, if the radical's in front like this, and they'll try to trick you sometimes like that, put it in the right order first. Put the radical in the back. And then you'll get the correct conjugate. Now, how do I multiply 4 times this? Think of it like this. Distribute, right? So, what's 4 times negative 2? And what's 4 times negative radical 7? That's easy, right? Okay. Sometimes you might have, a 4 plus a radical 3 or something. Then you have to FOIL the top also, okay? And simplify it. It's okay to have radicals in the top, not in the bottom. That's why we're doing it. So the shortcut, what's negative 2 squared? 4. Always minus, and what did I say? Whatever that number is, right? Because it's the square root of 49, right? Which would be 7, right? So what's 4 minus 7? Negative 3. Is there a number that goes into 3, 4, and 8? No. What if that was a 2, 4, and 8? Yeah, then we would simplify it like we've done in the past when we did the quadratic formula stuff. Then,
Well, just in the beginning, the very beginning, the minus 7, the 2 minus 7, or 2 minus radical 7 on the other side of the equation.
here,
Yeah, where's that come from?
it's called the conjugate. So these two are the same. All you do is change the sign between them to get the conjugate. Okay? So we put it in the right order, put the radical in the back. So that's a positive radical 7 and a negative 2. So that's why we wrote it like that. The negative 2 stays. Only thing that changes is went from plus to minus. All right, that's what we did with this one too. This was 5 plus radical 3. Only thing we changed was the plus to the minus. Okay, any other questions? Guys are doing good. I think that might be it.
Homework.
Yep.
Homework.
There you go. Good job. Thanks for paying attention.